Hey folks, this is a video still from section 11.2 where we talk about triangles and quadrilaterals and their definitions. So the first one is going to be the acute triangle. This is a triangle where all the angles are acute, less than 90 degrees. Here would be an example of that. The obtuse triangle is where I have a triangle and one angle is obtuse. So this would be an example of that. The right triangle is going to be a triangle where one angle in the triangle is a right angle. So all three of those talked about the angles in the triangle. Now, the next three are going to talk about the sides of the triangle. So a scalene triangle is where I have no congruent sides. So all three sides are a different length. Isosceles triangle, this is where I have two sides that are congruent to each other, two sides of the same length. And when we have this, we're going to use a tick mark to show that those two sides are the sides that have the same measure. An equilateral triangle is a triangle where all three sides are congruent to each other. So in this one, I could put a tick mark on all three sides showing that all three of those are the same length. Then we move on to quadrilaterals. So these are all definitions on quadrilaterals. The first one is the trapezoid. The trapezoid is a quadrilateral, four sides. It has at least one pair of parallel sides. So an example of this, you notice that in this case, the top and the bottom are parallel to each other. The kite, this is a quadrilateral where two pairs of adjacent sides or sides that are next to each other must be congruent to each other. An example of this would be something like that right there. Sorry, I erased a little bit too much. So here I have two sides adjacent, they're next to each other and they are congruent. And I also have another pair of two sides that are next to each other as well as congruent to each other. The isosceles trapezoid is the trapezoid that has congruent base angles. So here's an example, and what I've got here is these angles here at the bases are congruent to each other. What we also end up finding later on is that not only does that occur, but I also have these two sides here being congruent to each other. The parallelogram is a quadrilateral where I have two pairs of parallel opposite sides. So not just one pair of parallel sides, but now I have two pairs of parallel sides. The rectangle is a parallelogram. So if you go back to the last definition, I've got two pairs of parallel opposite sides, but I also have to have right angles. The rhombus is going to be a parallelogram. So again, two pairs of parallel opposite sides. But in this case, two adjacent sides are congruent to each other. So not only do I have parallel opposites, I also have two adjacent sides are congruent to each other. What ends up happening is all four sides end up being congruent to each other. The square is a rectangle. So you go back, a rectangle is a parallelogram. So I have two pairs of parallel opposite sides. I also have right angles. And then there's one more thing, two adjacent sides are congruent to each other.